In many rural homes and semi-rural properties, water exists as both an everyday utility and a quiet dependency. Most days, it remains unnoticed. It moves through a pressure tank. It comes out of a faucet. It shows up in small, ordinary actions: rinsing produce, filling a pot, washing hands, topping up a pet bowl. When it works, it blends into routine and disappears from attention. The surrounding work only becomes visible when reliability feels uncertain. Effort begins to collect in small, repeatable adjustments. Extra containers appear in garages and sheds. A second hose gets purchased just in case. People start tracking how long a stored supply lasts when it is limited to cooking and drinking. Someone checks a pump house more often. A filter gets replaced earlier than planned. A rain barrel is repositioned. A generator is tested, not because it is needed today, but because water systems often assume electricity, even when they are described as independent. Within that broader environment, where water is both ordinary and operational, Joseph's Well tends to appear as a DIY instructional format. It is packaged as plans and accompanying materials, rather than as a finished physical device. Structurally, it sits alongside other preparedness-style references: guides, schematics, parts lists, and build walkthroughs. These are materials meant to be used at a workbench, not consumed as entertainment. At first glance, it presents as documentation, something that can be followed, revised, and interpreted within the limits of whatever tools, space, and materials are already available. From the outside, the product behaves less like a machine and more like a recipe for assembling a machine. Joseph's Well is positioned as a digital program. The core offering is typically described as plans or blueprints paired with instructional guidance. In practical terms, that usually means downloadable documents and videos accessed through an online portal or delivered through a digital download sequence. Structurally, the material attempts to standardize a build process. It outlines a target device concept, a water-generating setup described as pulling moisture from the air through condensation-style mechanics. It includes a list of components expected to be sourced independently. It presents a sequence of assembly steps as a walkthrough, and it offers supporting material that clarifies wiring, placement, collection, and basic upkeep expectations. What it does not provide is a shipped product. Nothing arrives on a pallet. There is no technician. There is no factory-built unit. Even if marketing language uses confident phrasing, the underlying structure remains informational. It delivers instructions, not a finished system. Because of that, the format inherits the same limitations common to all instruction-first products. The experience depends on how clearly the material is written, on how well it aligns with real-world parts availability, and on how much interpretation is required when a listed component is unavailable, regionally uncommon, or incompatible with local power standards. The documentation can describe a system, but it cannot control the environment it enters. It also cannot remove the physical realities of condensation-based approaches. Airflow, humidity, temperature, energy input, and safe collection are not secondary details. They are operating conditions that determine whether the concept functions in practice at all. In day-to-day terms, an instructional product like this is not interacted with continuously. Most of the involvement is front-loaded. First comes reading and screening. The material is opened and examined to understand what the device actually looks like in physical terms. Not in marketing language, but in objects. What sits on the floor, what mounts to a wall, what connects to power, what drains into which container, what needs to be cleaned, what needs to be replaced. Then comes sourcing. Time moves away from the screen and into the physical world. Hardware stores, online orders, spare parts bins, borrowed tools, measuring tape, and return trips for the item that did not match the diagram. After that comes assembly. This stage is usually intermittent, an hour here, a weekend block there. Work pauses when a part is missing or when a decision point appears that the material does not fully resolve. Work resumes once those gaps are closed. If the build is completed, the interaction pattern changes again. The material becomes a reference rather than a guide. It gets reopened when something behaves differently than expected, when a maintenance step is unclear, or when the builder wants to adapt the setup to a different placement or power configuration. The overall involvement level is not passive. The format assumes a person is willing to handle electrical components safely, manage basic tool use, and make judgment calls when real conditions differ from what the documentation assumes. It also assumes acceptance of a central constraint. Performance depends on environment, not intention. In practical terms, this often looks like instructions sitting open on a phone or laptop near a workspace, competing with other household projects for time, attention, and patience. As a format, Joseph's Well centralizes one thing: a single pathway for assembling a specific device concept. It aggregates documentation. It attempts to make a complicated idea feel followable. It provides a frame for how components connect and how the system is intended to cycle. But several critical decisions remain outside the structure. Parts, quality, and equivalence remain external. If a plan names a component type, the builder still chooses the exact model, whether it is new or used, and whether it is compatible with other selections already made. Local safety standards remain external. Electrical work, condensation collection, and water handling intersect with real risks. The documentation can recommend approaches, but it cannot certify safety or compliance within a specific jurisdiction. Water handling remains external. Even when a system is described as producing drinkable water, the responsibility for safe storage, clean containers, sanitation routines, and filtration choices remains with the operator. Power economics remain external. Condensation systems require energy input. The material can describe power options, but it cannot determine whether a household can supply that energy consistently, season after season. Environmental feasibility remains external. Humidity and temperature are not minor variables. In some climates, condensation approaches are operationally limited for extended periods. Because these boundaries exist, the product's real scope is narrower than its branding. It does not address water as a category. It provides documentation for assembling a device concept that may contribute under specific conditions. Within preparedness and off-grid formats, Joseph's Well occupies a middle space. On one side are commercial appliances, expensive standardized units that arrive ready-made and are supported through conventional consumer channels. On the other side are improvised methods, tarps, solar stills, dew collection, storage discipline, and low-tech filtration routines that are inexpensive but often limited in output and consistency. This format positions itself between those extremes, not a purchased machine, not purely improvised. It proposes that a machine-like setup can be assembled without paying machine prices by translating general condensation principles into a home-built configuration. Whether that translation holds up cannot be known from a headline. Instructional products vary widely in how they handle real conditions. Some are tightly specified. Others rely on the builder already knowing what to substitute. Some appear beginner-friendly, while quietly assuming intermediate skill. Some look straightforward on video, but become complex when replicated with different parts. So the most accurate structural position is this: Joseph's Well is documentation that attempts to compress a build process into a packaged form. The only way to understand how complete that compression is, to see whether steps are specific or vague, whether lists are realistic, whether diagrams align with actual assembly, is to move through the material under real constraints. Supplementary material related to this format is documented in the description. From there, the remaining unknowns are practical rather than conceptual. How often a decision point appears without clear guidance. How dependent the process is on specific component types. How tightly the system, as described, depends on environmental conditions that cannot be adjusted. Those details do not surface in a single summary. They emerge slowly through reading, sourcing, assembling, testing, and adjusting. When the product stops being an idea and becomes pages beside real tools, real parts, and real limits. And that is where Joseph's Well ultimately exists, not as a promise, but as a folder of instructions sitting quietly within the physical reality it has to meet. 2.